probability. Directly we'll go for the content. It's one of the important topic under statistics in a practical case. When you talk about the real world situation, okay, when you talk about the real world situation, most of the cases will be using colloquially in our English language the term called as probably நடக்கும் இருக்கலாம். Okay. It looks like as if நம்ம கான்ஃபிடண்டா பேசாத மாதிரி இருக்கும்ல. இருக்கலாம், நடக்கலாம், வரலாம். ஓகே. சென்ட மரியா எடுக்க முடியுமா? தெரியல. அது மட்டும் தெரியலன்னு சொல்லு. Probably in accountancy, you might have read this term called as contingency. Remember? Contingency. So contingency is may or may not happen case. Yes, we already know this. May or may not happen case. Is a contingency same as probability அப்படின்னா exact meaning Englishல colloquial பாத்தீங்கன்னா somewhat the same. If you go for the exact meaning, contingency is something may or may not happen, but probability is something where you can go for the calculation and give whether it can happen or not. Okay. Probably in accounting standard itself, we have accounting standard AS. In accounting standard itself, we have something how the contingency event has to be recorded. Okay. Contingency event ஒன்னு இருக்கு ஒரு கேஸ் போயிட்டு இருக்கு அது கோர்ட் ஆஃப் லால வந்து எப்படி டிசைட் ஆகும் we want to record it பேட் டெட்ஸ்ல வருமா இல்லனா ஷோர் ஈவென்ட்டா கன்சிடர் பண்ணலாமா இதெல்லாமே பார்க்கும்போது எதை வச்சு பார்ப்பானா ப்ராபபிலிட்டி வச்சு தான் பார்ப்பான் ஓகே 90% will win in the case அந்த மாதிரி ஓகே so we may be using the term as probably or in all likelihood or chance probably this also in addition to that we'll not use it in a practical situation. Colloquial English language la use panna matom, but we have this concept also important: odds in favor and odds against. We play a game. I win. Abdin solradhukko you lose. Abdin solradhukko same. I'm like only we two are playing. Myself and you. I win. Abdin solradhukko you lose. Abdin solradhukko same. Only there are two players. So odds in favor nu solradhu or angle, odds against nu solradhu or angle. Okay. We have problems in this. We'll go to that part later. When you say probability, it's nothing but a branch of mathematics because we are going to do some part or some type of a calculation. And it's a very integral part of the statistics. So when you talk about statistics, immediately நம்மளுக்கு mind register ஆகுது measures of averages, dispersion, mean, median, most standard deviation. Next level, very important highlight is given for this area, probability. It's an integral part in statistics. When you go for hypothesis testing and estimation and all, we particularly deal in probability only. Apart from mean and apart from standard deviation, see, we have done the comparison table. You remember the 13 points, the full comparison table. From the comparison table, we were saying that mean is the best measure and standard deviation is the best measure from the measures and of averages and dispersion. Likewise, if you go for using mean, population mean, mu, and standard deviation, population standard deviation sigma, along with this, we'll be going for the hypothesis testing. Probably, if you're business math students, you might have studied this concept. Mu is equal to mu naught. Hypothesis one, null hypothesis. Mu is not equal to mu naught. Alternate hypothesis, H1 might be named in this. This is all dealing with the concept of probability. So, if we check the statistical measures, the measures of averages and dispersion, we have so many, and among that, we were saying that mean and standard deviation are playing a very important role. And if you refer those tables, you will be finding that it is helpful for further statistical analysis. It will be helpful for further statistical analysis. Under further statistical analysis, we will be taking the help of the probability in hypothesis and estimation testing. It's first applied by a group of mathematicians in Europe about 200 years ago to enhance the chance of winning in different games of gambling. So it's then developed by mathematicians and statisticians. So who are involved in this? All these mathematicians and statisticians are here. Okay, so let me go directly for the content. We have two divisions. Okay, we have two divisions. So we have two divisions. One is subjective in nature and one is objective in nature. When we say probability, we are following the objective probability only. Please highlight. When is subjective probability used? Probably some decisions are depending on personal judgment or experience, and probably because of the intuition or personal belief or because of the attitude or because of some error we are taking the decisions. So especially this is helpful in the case of where the environment is not certain, uncertain இருக்கு. நம்ம வந்து guessing work தான் பண்ணணும். அந்த மாதிரி cases and in the area of decision making management will go for subjective probability. Whereas if we go for the objective probability, we already know the recorded observations rather than a subjective estimate, then we'll take a measure on that. So when we talk, the whole content probability is depending on which subject? Objective probability only, not on subjective. We should be very confident with that. We'll go for a few definitions or terms. Before that, let me go for the board work. Just imagine I'm giving this activity to you. Okay. You have a coin in your hand. Can you tell me which coin you will get it? That is, which side of the face you will get it? I'll ask you to toss a coin. Which side of the face you will get it? Huh? ஒண்ணுதானே வரும். ஹெட்டா டெய்லா? அது சொல்லுங்க. ஹெட் வருமா டெய்ல் வருமா? என்னப்பா? What happened? டாஸ் பண்ணாதானே தான் தெரியும். குட். நல்ல வேலை ஆன்சர் சொல்லிடுவீங்களோன்னு நினைச்சேன். You did not answer, even though you know. It's an experiment. Everybody knows when you toss a coin, you'll get one of the two faces. What is the face named as? Head as one and tail as other. Okay. I asked this question to you. Which one you got or you will get? Okay. பதிலே சொல்லல. ஏன்னா என்னது? Toss பண்ணணும் ma'am. You haven't tossed. Toss பண்ணணும் ma'am சொன்னீங்க. Okay. Which means actually trial has to take place. Trialing. Trialing another. Tossing is the trial over here. If you toss, you will get the two outcomes. This is the experiment. Because we are talking about objective probability, we are talking about the recorded measures, recorded experiment. So it's already recorded, we are tossing and many have tossed already and we know that only these two things appear. Okay. But only when you try, which means what? The trial has to happen, which means what? Only when you toss, you can exactly say head will come or tail will come. Okay, so that's the difference between the term experiment and trial. So let me continue here. Experiment may be described as performance that produces certain results. Seems to be simple. But our intention is to not talk about experiment, to talk about random experiment. Please highlight, we are going to talk about random experiment. Okay, we are going to talk about random experiment. Random experiment is defined to be random. What do you mean by random? I want a 5 rupees coin. Who will give it to me? In the body, let the action on. Okay, you're taking a purse. Just imagine, you're taking a purse. In the coin எடுப்பீங்க. Okay, your girlfriend or boyfriend are given the coin. தருவீங்க என்கிட்ட? தரமாட்டீங்க. செல்லுமோ சொல்லாத தரமாட்டீங்க. You got a new coin. இப்பெல்லாம் அந்த 20 rupees coin வருதுல்ல வச்சுப்போம். You got a new coin. தருவீங்களா தரமாட்டீங்களா? அந்த மாதிரிலாம் பார்க்க கூடாது. 5 rupees கேட்டா பாக்கெட்ல இருந்து எந்த காயின் வருதோ 5 rupees தான். எந்த காயின் வருதோ கொடுத்துடணும். That's what you call as randomness. I take a coin, okay, whether it's 1 rupee coin or 5 rupee coin or 10 rupees coin or 1000 rupees coin, 20 rupees coin, whatever it is. I flip it, I toss it. டாஸ் பண்ணா ஒரு சைட்ல ஹெட் இருக்கும், ஒரு சைட்ல டெய்ல் இருக்கும். அது என்ன காயின் வேணாலும் இருக்கட்டும், அது யார் தலை வேணாலும் இருக்கட்டும். ஒரு வாட்டி சச்சின் தலையை போட்டாங்க, ஞாபகம் தெரியுமா? சச்சினோட கிரிக்கெட் மேட்ச்ல, டெஸ்ட் மேட்ச்ல, he was playing the last டெஸ்ட் மேட்ச் ரிட்டையர் ஆகிறதுக்கு முன்னாடி. ஸோ டாஸ் பண்ணுவாங்கல்ல கிரிக்கெட் மேட்ச் ஸ்டார்ட் பண்ணும்போது. ஸோ the coin was designed to honor him. ஏன்னா he is a record breaker in most of the cases. அதனால to honor him, சச்சினோட நேம் கிரெடிட்டுக்காக the coin was tossed. One side was Sachin head, other side is a normal இது டெய்ல். டெய்லாம் இருந்து இருக்கும் இல்ல, காயின் ஃபிளவர் அந்த மாதிரி இருக்கும் இல்லையா. That's what you call as randomness. யார் தலை வேணாலும் இருக்கட்டும், அங்க என்ன வரும்? தலைனா தலை தான் சொல்லும். Okay, one side is head, இன்னொரு side is tail. This is what you call as random experiment. Okay, so what do you mean by randomness? What do you mean by saying random? I ask or I say a coin is tossed. A coin. It doesn't mean or is not giving value to the coin, 1 rupee, 10 rupee. No. It's a coin is a coin. One side is printed something and another side is printed some other thing. No. One side is head and another side tail only. Okay, we'll not give special names and all. Second, I'll give a dabba. Okay, dabba. ஒரு சிட்டெல்லாம் போடுவாங்கல்ல அந்த மாதிரி ஒரு டப்பா. Okay, and I'll place balls in that. Okay, I place balls in that. It has green color balls, it has blue color balls, and so on. I asked to pick a ball. A ball means a ball. I ask you to pick a green ball, which means what? There may be 10 green balls in that. But which one you're going to pick? A green ball. There is no mentioning of anything. Okay. So when you say random, it is playing a very wider meaning, which means we have to treat everything equally. Question differentiate panina. Okay. So that's about random experiment. Trial, yes. The result will be known only after the experiment is done. Okay. Events, the results or the outcomes of the random experiment. Please highlight. See, I'm going word by word means it's such an important content. You should not talk just about an experiment. You have to talk about random experiment because we are talking about probability first thing. This event definition is asked in the exam. How it is defined? See, please check the results or outcomes of a random experiment. Okay, the results or the outcomes. Sometimes it might be combination of outcomes also. Okay, I toss 2 coins. What are the events you get? Head, head, tail, tail, head. Okay. The total outcomes is what you call as a sample space. So how it is defined? Per the set of all events. Set. The complete set theory on the one. Remember when I was handling set theory and permutation and combination, I was saying the concept use the probability. So when we apply the concept of sample space is defined as nothing but set. So all the applications, what are the union, intersection, what are the things we have studied? Okay, fit okay. So tossing of coin is an experiment. Tossing of any coin is random experiment. Tossing is a trial. Head and tail are the events or the outcomes. And you say the sample space is a set. So how you have to represent a set? You remember? Start with a capital letter. Okay. Usually this is a sample space. So we'll not use A, B, C, K, L, M, and all. We use capital S equal to open a bracket, close the bracket. We have 2 ways in representing a set. எப்படி represent பண்ணுவோம்? Tabular method, that is listing method, and tabular method. We'll not go for rule method. We'll go for listing method because you're going to list it out. Because all recorded only. We are not going to find it. Okay. So head or tail is separated by commas. Okay. Continuing. Types of events, please highlight. Very, very important. We'll say the first classification based on number of trials. I request you to make a note of it. Please join. Based on number of trials, if it is only 1 trial, so number of trials is 1. Usually we denote with the help of n. What is n? Usually cardinal number. Here we take the usage of small n, which is the number of trials. If the number of trial is 1, then it will be called as simple or elementary events, which means it cannot be decomposed further. See, you take a coin, you toss it, you get head or tail. Split whereas if we go for 2 coins, what happens? Head, tail, head, tail, head. So further you can decompose. Head, how you got this head? First coin shows head, second coin shows head. Further split okay, that's what you call as decomposition can be done into 2 or more events. So you call this as composite or compound events. The alternate nates are also important. So this is first category. Second category, mutually exclusive, exhaustive, and equally likely events. The second category, mutually exclusive, exhaustive, and equally likely events. I toss a coin. I go for a very simple example. I toss a coin. Okay. What are the events you get? Head or tail. Please make a note. If head comes, tail will never come. Am I right? See, I'm using the word tail will never come. சும்மா will not come சொல்லல என்ன சொல்றேன் tail will never come ஆமா இல்லையா நம்ம random experiment சொல்லும்போது tossing a coin will give only 2 events, head or tail. One side is the head, another side is the tail. If head appears, tail will not come. Tail appears, head will not come. Okay. This way if you talk, you will call this as mutually exclusive event. Probably let me define getting a head. Okay. Getting a head is event A. Okay. This is set A where only H is there. Getting a tail is event B. Okay. Head comes na, tail will not come, tail comes, the head will not come. So for this mutually exclusive, I can write it as A intersection B is equal to null set. What do you mean by disjoint set? You remember? Disjoint means what? If you go for the Venn diagram, your disjoint set will look like this. Remember? The different cases part of. So this will be A, this will be B, where A intersection B will be null, empty. So A intersection B will be a null set. So if you define the event as sets, then you name this as set A, set B, then it will be A intersection B is equal to empty null set. So this can be taken as a condition. If A and B are represented in terms of sets and this set becomes disjoint set, then we call this as mutually exclusive. Okay. Exhaustive. If I define in the same way, I can clearly say A union B will be the whole of sample space. I toss a coin. So I'm sticking with the same example. I toss a coin. What do you get? What do you get? உங்ககிட்ட கேட்கிறேன் என்னப்பா வரும் என்ன மேம் ஹெட் வரும் இல்ல டெய்ல் வரும் how you say head வரும் or tail வரும் okay so head is named as event A and tail is named as event B and you say head or tail இதெல்லாம் என்ன இருக்கோ அதுதானே வரும் அப்போ A union B should be equal to the whole of sample space. Equally likely, how many heads and how many tails you have? One head and one tail. Okay, which means the cardinal number n of A is how much? 1. N of B is how much? 1. This is what you call as equally likely. Equal chance. நம்ம ரெண்டு பேரும் ஒரு கேம் விளையாடலாம் ஓகேயா என்ன கேம் மேம் கிளாஸ் அப்புறமா எடுக்கிறீங்களா திஸ் இஸ் அ கேம் இட்ஸ் அ கியூப் 1 2 3 4 5 6 இருக்குன்னு வச்சுக்கோங்க ஓகே இது பண்ணல இந்த சைடு வரும் ஸோ 1 2 3 4 5 6 இப்போ அந்த டை வந்து நம்ம த்ரோ பண்றோம் நீங்களாம் விளையாடிருப்பீங்க இந்த ஸ்னேக் அண்ட் லேடர் ஓகே ஆரன்ஸ் யூ ரிமெம்பர் திஸ் கேம் விச் மேட் ஆர் பிளேட் டப்பா டப்பாலாம் போட்டு ஞாபகம் இருக்கா ஓகே எல்லாரும் இந்த வேலை தானே சம்மர் ஹாலிடேஸ்ல இதான பண்ணிருப்பீங்க ஓகே இப்பெல்லாம் மாறிச்சு லூடோ business game or snake or ladder okay we throw the die okay if one appears then only start the game அப்படிதான் ஆக்கு வைப்பாங்கல்ல அவன் கூட ஒன் வரவே வராது சுத்தி வந்துடும் கேமே முடிஞ்சிடும் if one appears you throw the die if one appears you will start the game I have a special case okay 1 2 3 4 5 6 எது வந்தாலும் I start the game சொல்லுங்க என்ன பண்ணலாம் மேம் கூட கேமே ஆட வேண்டாம் போங்காட்டமா இருக்கு சொல்லுவீங்களா இல்லையா சரி பிளேயர்ஸ் தான் ஈக்குவலா இருக்கும் தட்ஸ் அபவுட் ஈக்குவலி லைக்லி we have to play a equal game so equally likely which means n of A is equal to n of B so we'll be having the equal number of events n of A is equal to n of B further instead of using the term equally likely we'll be using the term equiprobable probability equate பண்ணுவோம் அப்போ வந்து என்னவா மாறணும்னா P of A equal to P of B ஆ மாறணும் நோட் பண்ணிக்கோங்க எப்படி இருந்தாலும் நம்ம படிக்க போறோம் okay like 70% I'll be finishing by tomorrow so this is the second classification mutually exclusive exhaustive okay exhaustive and equally likely or in future we'll be using the term as equiprobable okay equiprobable okay let me go for another one example to understand in a better way எல்லா events எல்லா experiment இப்படி தான் இருக்கணுமா not necessary let me go for throwing a die okay please join what are the outcomes one usually die means cubic die okay all the sides we have numbered as 1 2 3 4 1 dots na 1 2 dots na 2 yeah so 1 2 3 4 5 and 6 I represent this is sample space so S is equal to 1 2 3 4 5 6 let me define event A okay which is containing 1 event B which is containing the remaining which means what if A appears which means what 1 falls down then we can start the game if B appears 2 3 4 5 6 appears you cannot start the game இப்போ சொல்லுங்க இது mutual exclusive yes please mutual exclusive means what by definition if this appears that should not appear if you're talking about A B and C if A appears B and C should not appear okay Now tell me, A and B. A appears, which means 1 appears, which means what? 2, 3, 4, 5, 6 has never appeared. இல்லைன்னா என்ன பண்ணலாம்? A union B equal to null set check பண்ணலாம். Go by the definition and also go by the set theory concept. A intersection, sorry. A intersection B is equal to null set. Either you go by the definition or go by the set theory. Definition ரெண்டுமே தெரியணும். ஏன்னா one by நமக்கு வரும். So A intersection B equal to null set anger. Yes, there is no common elements, null set. What about exhaustive? A union B equal to the whole of S? Yes. What about equally likely? N of A is 1. N of B is 5. Not equal. Okay. Let me go one more example. The same, a die. Okay. In the sample space, this one. Let me define A as multiple of 2. Yes, what will be in the event in the sample in the set A? Multiple of 2. 2, 4, 6. B. Multiple of 3. 3, 6. Tell me, mutually exclusive or? No. If A appears, B should not appear. A appears, 6 appears. இது ஏன் சொல்வீங்களா B சொல்வீங்களா? Or is A intersection B equal to null set R? இல்லையே 6 இருக்கு A intersection B. So this is not mutually exclusive. Exhaustive. If I pool A union B, what I have to get? The whole of the sample space. 1, 2, 3, 4, 5, 6 already one. But what I am getting here? No 1 is there. 2, 3, 4, 6 alone. No 1 and 5 is there. So it's not exhaustive. Okay. Equally likely, N of A is 3. N of B is 2. Not equally likely. In the Mari Indishna, we cannot play the game probability. There's a very important definition will follow from the set of events. We'll go for 3 types of definition in probability. The first definition says the event should be mutually exclusive, exhaustive, and equally likely. Then only you can talk about probability definition. Else you cannot talk about it. Is it okay? So if you want to make a note of anything, you can please. Please join. Mutually exclusive events request you to have the alternate word also in your mind. Incompatible events in சொல்லலாம். Not more than one events will occur simultaneously. Or you can define this as happening of one will exclude the happening of the other. Excluding what? The other will not come. Occurrence of one event implies that the other event has not occurred. Occurrence of one event implies the non-occurrence of the other. Exhaustive events, one of the events in the sample space must necessarily occur. Okay. One of the events in the sample space must necessarily occur. This is by definition. Equally likely events, also called as mutually symmetric events. Mutually exclusive வேற mutually symmetric வேற கொஞ்சம் ஞாபகம் வச்சுக்கோங்க. Symmetricனா என்னது? Same சொல்லுவாங்க. Symmetric. Or we use a term called as equiprobable. It's nothing but equality of the events. No event is expected to occur more frequently as compared to the other events, which means what? Frequency of the event should be same. A happens where there is 3 chance now. B happens, there is also 3 chance. So probability of A and probability of B will be equal. Okay. So this is the one I was discussing. Then we'll go for the next category of events called as finite events and infinite events. If the number of events is finite, we call it as finite event. If the number of events is infinite, we call it as infinite event. Probably how we guess this is number of trials. Number of trials finite இருந்துச்சுன்னா events finite இருக்கும். Number of trials infinite இருந்துச்சுன்னா events infinite. Fourth one, unbiased and biased events. Getting events on performing is what you call as unbiased. Biased takes the word meaning error. Not getting the events on the performance. See, usually when you go for any example, they say that unbiased coin is tossed. அப்படின்னா error இல்லாத coin. அது எப்படி error இல்லாத coin? Defect. No, that doesn't mean that way. See, I toss a coin. What you'll get? What is the random experiment? Either head or tail you'll get. So either head or tail will definitely turn up. Okay. You're tossing a coin in a sandy floor. Okay. One side of the coin showing head, another side, another side showing tail. இப்படி நிக்குது coin vertical. One side it is head, one side it is tail. Okay, so tell me which side has turned up? Which எல்லாத்துக்கும் ஒரே பதிலா தெரியல மேம் கரெக்ட் தான் ஆன்சர் இஸ் ரைட் தெரியல one side is head another side is tail na it's not a experiment as per the probability definition so the event should be unbiased not biased okay fifth set definitely it will come it is called as sure event definitely it will not come it is called as impossible event okay last category I'm not discussing now I'll discuss later okay because some 50 or 60% of the probability has to get completed then only I'll go for this category so not immediately now okay so keep this pending so totally we have 6 different classifications 5 are discussed now if you want to go through please go through check whether all the 5s are okay go for each and every word yeah actually we have 3 definitions let me go for the first one is the real life practical definition we are using like day to day life example if I talk about tossing a coin getting the head is the event for you defined okay getting a head is the event for you defined let me name you as A okay you have to get the head அப்போ இந்த event name என்னன்னு சொல்லணும்னா event A event B getting a tail okay they'll ask you what's the probability of getting a event A which means what is the probability of getting the event head yes what's the probability you say 1 by 2 how you say this 1 by 2 there are totally 2 events head or tail okay which means total number of events in the denominator and one is only one head is there which means only one favorable event is there so this in the numerator will have favorable events this is the normal definition we use that's the very first definition called as the classical definition of probability okay there's another word for this classical definition can also be called as a priori definition which means is the very first definition we are using it from the beginning. Here we'll be defining the number of finite elementary events. Please highlight n. Usually we name this as n number of events or number of trials. Okay. Here we name it as number of events. N finite elementary events and equally likely are in the favorable events. I define it as NA, which will be equal, less than or equal to n. This is asked in the exam once. Okay. What is this NA? I'm picking from n. Okay. And this NA should be less than or equal to n. Correct? How many events I have totally? For example, I have a box. Dabbalar balls irukku. I have 10 balls. And all these 10 balls are equally likely. Which means what? All of same color and only one are there. There is no 3 green and 4 yellow. All are different color. Sorry, not same color. All are different color and one ball are there. All balls are equal in nature. In that, I am asking you to pick a rainbow color ball. Rainbow color means what? Vibgyor. Out of the 10 balls, 7 balls will be Vibgyor colors. அப்போ இந்த NA ங்கிறது என்னது? NA is the Vibgyor color 7 strictly less than N. And if I say you can take any one ball. Okay, இந்த kids எல்லாம் கிண்டர் கார்டன்ல போடும்போது இதான் சொல்லுவாங்க உங்களுக்கு பெரிய ஆக்டிவிட்டி என்னன்னா அந்த டப்பால போய் பால் எடுக்கும் கரெக்டா ஓகே பெரிய பசங்க சின்ன பசங்க see this NA can be less than N or it can be equal to NA. So how you define probability of A? Please join probability of A. This is not the probability definition. It's not yet over. This is one part of the definition. We define this as NA by N. Okay, what is this N? Total number of equally likely. N is total number of equally likely. Okay. NA is the equally likely events favorable to A. Because we are using the script A, we say favorable to A. So number of equally likely events favorable to A divided by total number of equally likely events. But still the definition is not over. If I have a set of this type of events, among that I take m number of events, and this m may be equal to less than or n, and it can be composite in nature. எப்படி இருக்கு இங்க finite, இங்க எப்படி இருக்கும் composite இருக்கலாம், and mutually exclusive, exhaustive and equally likely. Then I can define MA, which is less than or equal to M, favorable to A. Okay, favorable to A. Then I define the probability of A as MA by M, not NA by N. If I talk about finite events, then NA by N irukkalam. But I am talking about composite events. I'll talk about MA by M. So this is nothing but number of mutually exclusive, exhaustive, and equally likely events favorable to A divided by number of mutually exclusive, exhaustive, and equally number of elements total. Here it is favorable in the numerator. Here it is total in the denominator. Okay. Yes, please have a glance. I'll definitely explain once more time for you. One more time for you, please. Here I have to remember these alphabets. One is N, one is NA, one is M, and one is MA. The relationship between N and NA. NA is less than or equal to N, and the relationship between M and MA. MA is less than or equal to M. Not only that, there exists another one relationship between N and M, where M is less than or equal to N. So how many relationships are here? 1, 2, 3. Okay. And the nature of N. How the N is defined here? Finite elementary events. Of simple events. You are tossing one coin. We'll talk about this one. Okay. So simple events. In that case, equally likely will be there. If you're talking more than one trial happening, then you talk about M number of events. Then how M is defined, nature of M. Composite events, not only equally likely, it has to be mutually exclusive, exhaustive, and equally likely. Is it okay? Then when we say NA, it's favorable, number of events favorable to A, and MA, number of events favorable to A. Okay. NA is talking only about equally likely. MA is talking about mutually exclusive, exhaustive, and equally likely. Marandaradinga, okay. So this is about the definition, is often repeated. Okay. If your exam is tough, na, idalana romba pudipanga. Konjam careful arunga. Let me continue. The trial, what you do. See, only on trial we get head or tails, right? The trial, what you do, is named as Bernoulli trial. Bernoulli, or what you call as Laplace. அவங்க தான் இந்த கான்செப்டை வந்து மூவ் பண்ணாங்க. That's why. And it's based on prior knowledge only. Because objective in nature, not subjective. We have some demerits or limitations. What's the main limitations? N should be finite. If it is infinite, you cannot do this. Assumption events must be equally likely or equiprobable. Okay. And limited applications only. Like when you talk about coin tossing or die throwing, then only you can use it. And it's not applicable in the field of uncertainty or where you don't have prior knowledge. Okay. Just or features or corollaries என்னன்னா சொல்லிக்கலாம். First one, when probability of an event happens to be 0, we call this as an impossible event. Null set number இருக்கா? Null set எத்தனை elements? Number of stupid students in my class. என்ன silent இருக்கீங்க? No தானே? Okay. Probability of stupid students in my class. 0. Impossible event. P of A. 1 minus sure event. Sorry, not 1 minus sure event. Probability of A is equal to 1. It's called as sure event. Okay. How you define the range of probability is probability of A to this extent, lower end, it can take the value 0. So it can never be negative. And to that extent, maximum, it can take the value 1. அதனால இங்க less than or equal to use பண்ணிருப்பாங்க. It's not this way used. It's this way used. Please highlight. Less than or equal to. So, if you put it in range, you write it as 0, 1, close to brackets. Once asked in the exam, A, 0, 1, B, 0, 1, C, 0, 1, D, 0, 1. What's the answer? A. Okay. Impossible events to 0, sure event to 1, in between lie agala. So in that case, if you take the minimum value 1, which means what? Inclusive of 1, and maximum value of 1, which is inclusive of 1. Second, See, we were defining that if A occurs now, B will not occur. Yeah. So winning, I'm talking about winning the game now, but something called as losing the game also. So if I talk about happening, I'm talking about not happening also, right? There is a 40% chance it may rain, which means what? 60% it will not rain. Okay, if I talk about the event A, I can equally talk about the event complementary to that, which is nothing but a complementary event, is somewhat equal to the complementary set. So here we use the notation as A dash or A complement or A bar for non-occurrence of the event A. Please highlight, this is often repeated questions. We know that, see, A is an event. A is a set. A dash is a set. We say A and A dash are complementary set. So you can write A intersection A dash is equal to null set. Am I right? இதே வந்து இங்க ஈவெண்டா பாக்குறீங்கன்னா this nothing says they are mutually exclusive. Am I right? A and A dash are mutually exclusive. A comes now, A dash will never come. A dash comes now, A will never come. And if you talk about the probability value, P of A and P of A dash will be equal to 1. ஆமாம்ல ரெண்டுமே இன்டர்செக்ஷன் வந்து என்னது நல் செட்னா ஆப்வியஸ்லி ரெண்டுமே ஆட் பண்ணா உங்களுக்கு என்ன வரும் ரெண்டுமே பூல் பண்ணா உங்களுக்கு வந்து the whole of the sample space வரும் why we are talking about the sample space is exhaustive also exhaustive the whole of the sample space வரும் so if I say that probability of A is MA by N then P of A plus P of A dash is equal to 1 means I can get the value P of A dash as 1 minus P of A which is equal to 1 minus MA divided by M which is equal to M minus MA divided by M. Am I right? So that's about this point, second point. Okay. Just check whether you're okay with first and second point in detail before I go for the third one. Make it faster. First and second. Kindly join. For the third one, odds in favor of A and odds against A. A is an event happening of anything. Let it be a coin tossing or throwing a die or taking a ball, whatever it is. Okay. If all you have the prior knowledge about the event and you can guess how many events will occur, then it's fine. So A is some event happening. If the event happens and we take the probability, we define as P of A. Am I right? This is the definition. How you read it? Probability of A. Okay. And so far from the earlier definition, we have defined this as MA by A. Sorry, MA by N. Whereas if you talk about the not happening of A, we usually mention this as A dash or A complement, whatever it is. So we write this as probability of A dash, probability of non-occurrence of the event A. How you read this one, Pa? How you read this one? Probability of occurrence of A. Okay. How you read this one? Probability of non-occurrence of A. Okay. So here you write it as, yes, how we write this one? Now, just now we had discussed M minus MA divided by M. So we know this concept already. Now we have to go this concept related to in favor and in against. When we use the term odds in favor or odds against, we are trying to express this in the form of ratio. Okay. Odds in favor. So let me go for this concept. Odds in favor. Now, I am talking in point of happening of A. Please make a note. Odds in favor. Now, I am talking in the point of happening of A. So let me write it over here. Happening of A. Is it okay? Happening of A. Okay. I'm talking in favor of happening of A. You remember the ratio format, how we express it? A is to B. Am I right? So there will be one event preceding and one event subsequent. Consequent and subsequent event pattern. Okay, so here When we talk about happening of A, it should be happening of A is to non-happening of A. So this should be the order. Okay, let me finish it off. Please join. After this, after that, you can make a note of it. First happening, then non-happening. If I talk about first happening, then what is the probability? MA by M is to M minus MA by M. Yes, you can equate. Usual ratio and the format simplified formula. So here the denominator are same. So directly I can go for comparing the numerator. So I can write this as MA is to M minus MA. This is what you call as odds in favor of A. So sometimes they will not ask you to find the odds in favor of A. Sometimes they will give this format and they'll ask you what's the odds in favor. அப்ப நீங்க ரிவர்ஸ் வந்து போகறமா. Okay. Then let me go for odds against. Let me finish it off. Odds against A. This is discussing in point of not happening. Okay. Not happening of A. So according to this order, which will occur first? Which has to be in order first? Not happening of A, then the event should be happening of A. So just the reverse format looks like, okay. So this is M minus MA divided by M. This is MA divided by M. Because the denominators are same, I can directly compare the numerators and I can put it in the simplified form. So this is M minus MA is to MB. So if this format is given, okay, this format is given and they're asking you to find what is the probability of A. Which is probability of A here? I have not yet finished. Please join here. I am not yet finished. Yes, if this format is given, this one or either this one, okay, and they're asking you to find the probability of A. Yes, from here, which is the probability of A? So what's the probability of A? How you write it? MA divided by, how you get M? Because I have mentioned here, you cannot say M, right? How you got M? See, this is happening. This is not happening. From the earlier property, P of A plus P of A dash is equal to 1 சொல்லிருக்கோம். அப்போ இது ரெண்டுமே add பண்ணா உங்களுக்கு என்ன வரணும்? 1 வரணும். So this and this, if you add put together, you get the total probability. So MA plus M minus MA. So MA and MA will get cancelled. So denominator will be M. Likewise, here, odds against, see this word will be given. Odds against is given. Okay, odds against is given. What's the probability of A? This is the probability of A. A is to B ratio format la B la irukla subsequent term la irukla adudhan. So this is probability of A. Is it okay? Sometimes the question will be odds against A dash. Odds against A dash. அப்ப full concept ulta ஆயிடும். Against A தானே பேசிட்டு இருக்கோம். Odds against A dash னா என்னது? They're talking about odds in favor of A. Wordings la கொஞ்சம். Question number 1. A coin is tossed 3 times. How many times? 3 times. So please try to imagine the probability. So what would be the not probability, sample space? What are the events you will have? 3 times means I have a coin, you have a coin, and another friend of ours have a coin. So I'm getting ahead, you're getting ahead, and the other person also getting ahead. So head, head, head. Or it can be tail, tail, tail. So this is how we got this one. Head, 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 tail, head, tail, head, head, tail, 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 head, head, tail, head, tail, and tail, tail, head, and all tails. Okay. So idhula edavadhu problem irukka? Idha frame பண்ணிடுவீங்கல்ல? Okay. A coin is tossed 3 times. What's the probability of getting 2 heads or at least 2 heads? Please remember, always when we go for this discussion and or, this is in terms of normal wordings, description and or. If you want to go for arithmetic operations, and will be taking the form multiplication or will be taking the form addition. If you want to go in set theory operations, and means what? Intersection, or means union. You should not forget this one. Okay. So here we have getting 2 heads or at least 2 heads. So getting 2 heads, what is the probability? So getting 2 means exactly 2 they say. So this is 1. Okay, this is 2 and I think 3. So it's 3 by 8. Or, so at least, then you're going to add only. At least 2 heads. So it can be more than 2 heads also. So 1, only 1, right? So already we have 1, 2, 3. And along with this we have this. So it's 4 by 8. Okay. Or what you can do is getting two heads is 3 by 8 or means addition. At least two heads like already cover airko, but remaining only one head I have to consider. So 1 by 8. So this will be equal to 4 by 8. You should not take 3 by 8, 4 by 8 and add and put it as 7 by 8. Now which corner? Okay. So when we see this is a wider set. Illa? See, you know this format. We have A intersection B and A is contained in B. You remember the cases we have drawn? Venn diagram. If A is contained in B, then A intersection B will be what? A intersection B will be A itself. If you talk about A union B, A union B will be B itself. It's given as two heads or at least two heads means at least two heads comes as a big set. So you can directly take the value as 4 by 8. Okay. So the answer is 4 by 8. Is it okay? Shall I go for the second question? A dice is rolled twice. Okay, what is the probability of getting a difference of 2 points? So what do you mean by getting a difference of 2 points? I get a face 3, you get a face, I get 1, you get 3. So what's the difference? Minus 2. 1 minus 3. Okay. I get 3, you get 1. What's the difference? You have to consider this one and this one both. Nothing is mentioned, you have to consider both. In case they say, what's the probability of getting a negative difference? Let me work out this problem. It's actually a easy problem only, but you have to focus on negative and positive word. So what are the events for two dice is rolled, right? And you have to get a difference of 2 points. Okay. So what's the way? I'm getting 1, you're getting 3. So we get a negative difference 2. I'm getting 2, you're getting 4. Okay. I'm getting 3, you're getting 5. So this is for negative difference. If I go for positive difference, I get 3, you get 1. 4, 2, 5, 3. Choice right? 6 and oh, I missed that. So 4 and 6 here, 6 and 4. So totally how many here? 4 events. Here also 4 events. If you add, you get totally 8 events and 2 dice are rolled. So what are the total number of events? In the denominator, you'll get 36. How you get 36? 6 part 2. Okay. How many events in one throw? 6 events. How many number of trials? So 6 part 2. Okay. So it's 36. 8 by 36. This is a problem. If they are giving us negative difference, your answer will be 4 by 36. If they are say as positive difference, then your answer will be 4 by 36. Because in the question is mentioned only as difference, you have to take 8 by 36. This was asked once. What is the probability of getting a negative difference later in our exam? Okay, so please focus on this. If you want to make a note of this one, yes, please. Should I take over? So number 3. Two dice are thrown simultaneously. Find the probability that the sum of points on the two dice would be 7 or more. So check when you get 7. For example, 3 and 4 is 7, 1 and 6 is 7, 2 and 5 is 7. Okay. And more also. So maximum you can get as one faceless 6, இன்னொரு faceless 6. Maximum you can get a count of 12. So check when you are getting 7, when you are getting 8, 9, 10 and 12. And you have to take or. So add everything. Okay. So for getting a sum of 7, 1, 6, 2, 5. So how many you have here? 6. For getting a sum of 8, you have 5. And here it is 4, 3, 2, and 1. Usually it will go in this order only. Triangle, inverted triangle. Madhuri. Okay. If you want to check a sum of 6 means it will be more. Okay. So here it is 6 plus 5 plus 3 plus 2 plus 1, 21 by 36. Okay. Fourth one, what is the chance of picking a spade or an ace, not a spade from a pack of 52 cards? This is often repeated question. What's the chance of picking a spade? Okay. How many spades will be there? Totally 13 cards. Set of spades now 13 cards. So picking a spade, there is a possibility of 13. There is favorable event is 13. And it's also given an ace. And how many ace will usually have? 4 ace. And it should not be of spade. So leave off the spade ace. So totally you'll get 3 is given or. So 13 plus 3 divided by 52. 16 by 52. Okay. Fifth one. Find the probability that a 4-digit number comprising the digits 2, 5, 6, 7 would be divisible by 4. This is a permutation problem. We have to find a 4-digit number and only 4 digits are given. அப்போ எப்படி மாத்தி போட்டாலும் you get a 4-digit number. Okay. And all the numbers are different. But what the condition given is it should be divisible by 4. So numerator by denominator problem. The denominator is the total different 4 digits number you can get it. How many numbers you have? NPR. How many numbers you have? 4. How many digits you have to form? 4. So 4p4 which is 4 factorial which is 24. Okay, denominator is fixed. Numerator what they say? It should be divisible by 4. Probably நீங்க lower class ல படிச்சிருப்பீங்க. Last two numbers divisible by 4 na all other remaining will be divisible by 4. Okay, so last two divisible by 4. And moreover, it's the divisible by 4 na it should be an even number. இல்லையா? So if you pick the even number, I take the last two places alone. If I pick the even number, here it can end with 2 or 6 alone. Am I right? So this can be, what are the options? This can be 52. I'm just combining all the options. This can be 52 or it can be 56 or it can be 72 or it can be 76. அப்ப எத்தனை options இருக்குங்க? 4 options இருக்கு. And remaining it can be done in remaining 2 numbers. It can be done in 2 factorial ways. So 2 factorial into 4. It's a permutation problem. 4 so denominator is fine, right? Denominator how you got 24? It's a normal problem. I can fix with 2 or 5 or 6 or 7, but they say the number should be divisible by 4. If the number to be divisible by 4, this last two place should be divisible by 4. அப்போ and even number இருக்கணும் 1 digit place. அப்போ இங்க 1 digit place even number இருக்கணும்னா it can fix with 2 or 6 alone. Okay. So I go for all the combinations with 2 and 6. So what are the combinations you can take over here? Only for these 2 digits. I can take 52. I can take 56. Okay. 72, 76. See, this 1 digit has to be 2 or 76. 2 or 6 only. So remaining combination of 52, 56, 72, 76. Okay. So what are the different options? 1, 2, 3, 4. So last 2 digits can be fit in 4 different ways. And if I fit with 52, what are the remaining 2 digits here? 6, 7. அப்போ 4 digitல 2 digit fit பண்ணிட்டோம்னா remaining 2 digits will take this as 1 way into 2 way. So this can be done in 2 factorial way. So 2 factorial into 4 which is 2 into 4, 8 different ways la நீங்க fix பண்ணலாம். So the answer is 8 divided by 24. Okay, this is completely a permutation problem. Is it okay? Please go through. If it's okay, we'll go for the next problem. Is it okay? Should I continue? Sixth problem. A committee of 7 members is to be formed from a group of comprising 8 gentlemen and 5 ladies. So how many gentlemen are here? Men are 8, ladies are 5. How many members a committee? Here is 7 members. Okay. What's the probability that the committee would comprise 2 ladies? A option. B is at least 2 ladies. Totally, how many are? See, if I consider this as a combination problem, I can simply work out and leave it. But I'm considering this as a probability problem. You have to make a note of this word. Probability nu kuthirukanga paranga. Okay, this will look like a normal problem, and you may be starting working as a normal problem. It's given as probability, so you have to consider this as two problems, one for numerator and one for denominator. A committee of 7 members has to be formed. Okay, don't go for the condition because denominator will have no condition. Only the numerator will have condition. So how many are totally here? 8 plus 5, 13. Huh? Among the 13, you have to select 7. So 13C7 will be the denominator. For numerator, go for the first subdivision. We need to have 2 ladies. The remaining can be gents. Okay. So how many gents are here totally? 8. So 8C5. Okay. 7 only, no? 8C5. It's multiplication or addition? That group need to have 2 ladies. Yes, multiplication. Gents and men's and women. So it's multiplied with among the 5, I'm choosing 2. So 8C5 divided by 8C5 into 5C2 divided by 13C7. This is first one. Here they say at least 2 ladies. Appa enna options varo? Men, women. 2 ladies and remaining 5 would be men. 3 ladies, remaining 4 would be men. 4 ladies, remaining 3 will be men. Or 5 ladies, remaining 2 would be men. You have to go for all the combinations. Okay, it's given over here. Yeah. So all different combination try பண்ணிட்டு எல்லாமே add பண்ணி divide by போட வேண்டியது. Okay. So that's about 6th one. So 6 problems done. You can go for a glance. If any doubts, we'll discuss. Second definition called as statistical definition, also called as limiting form of probability. See, in the earlier case, what happened is only when the cases where n is finite, we can talk about the definition of probability. So that was a very big limitation. To overcome that limitation, we have this definition called a statistical definition. It's developed by British mathematicians. We say it's a limiting form because here we are talking as n being infinite. Okay. Either the format n tends to infinity. Okay. N being infinite means n tends to infinity. Actually, we read this as n tends to infinity. We read this as n tends to infinity. We say that it's a very big number. Infinity is a number. Okay, it goes on and on and on. N tends to infinity. So how you define P of A is, see, so far we were talking about n being equally mutually exclusive, exhaustive, and so on. Okay, but here we will not talk in that way. We'll directly say what is the total number of events n. N is not the number of trials, number of events here. Okay, n number of events. And what is the event favorable to me? F. Why I use F here? Because I'm going to talk about frequency. Because I'm defining this in the angle of statistical definition. So stats la vandu nama frequency that F is used. And because n tends to infinity, we have to take the limiting form. So limit n tends to infinity. This is the probability definition under statistics. So what do you mean by FA is? A is occurring FA number of times. So random experiment is repeated a very good number of times. Say n under an identical set of condition, and we consider FA in that set of random experiments. Applicability, please make a note of it. இதுல பெருசா ப்ராப்ளம் ட்விஸ்ட் எல்லாம் இருக்காது, பட் கண்டென்ட்ல இருக்கலாம். Limits should exist and should tend to a finite value. These two conditions. Limits should exist and should tend to a finite value. Can you just go for this problem? Question number 7. Don't treat this as a probability problem. Treat this as a normal statistical problem which we discussed in the earlier topic. In the angle apart. So it will look like a normal statistical problem. Here the table is giving the details of the wages and the number of workers who get the wages in this range, right? So here, if I talk about the range 110 to 120 rupees, how many number of workers get in this range? 5 number of workers and so on, okay? If a worker is selected at random from the entire group of workers, what is the probability that his age would be less than 50? There is nobody less than 50 mentioned. So this becomes an impossible event. 0 divided by total number of workers, I think 150. So 0 divided by 150. His age would be less than 80, which means what? Add this one, add this one, and add this one. So what's the total? 74 by 150. So you can manage this one, right? So that's about question number 7. The problem they will not ask you to find the limit and all. Okay, limiting definition limits. They will not ask you to take the applications of limiting definition, the calculus. Okay. Operations on sets we know A union B, A intersection B, A minus B, and A dash. Before going for question number 8, I want to go for the board work. You need not copy anything. I'll give you time later. Okay. Please join with me. Try to understand the concept. It's quite important. You remember we were discussing a theorem on sets, addition theorem on sets. N of A union B equal to N of A plus N of B minus N of A intersection B. Okay. I divide throughout by N. N is the total number of events. So what happens? N of A union B divided by N is equal to N of A divided by N plus N of B divided by N minus N of A intersection B divided by N. Okay. This is nothing but the probability definition of A union B. Am I right? See, in the numerator, you are getting the events favorable to A and B, A or B. Okay, so this will become like P of A union B, and this is P of A. This is P of B minus P of A intersection B. Okay, so far is clear, right? Under the set theory, we were discussing two addition theorems. One is on 2 sets and one is on 3 sets. P of A union B union C is equal to, here we will not use that one. Okay. Maximum will go for A union B only. So P of A union B equal to P of A plus P of B minus P of A intersection. We will discuss different cases. Let us go for case number 1. Where A and B are given to be mutually exclusive. Okay. A and B are given to be mutually exclusive. Then what happens? A intersection B will be a disjoint set. N of A intersection B will be equal to 0. So P of A intersection B will be equal to 0. You agree with me? Is it clear? So when when A and B happens to be mutually exclusive, then this theorem now you can read this as P of A union B is equal to P of A plus P of B. Okay. I'll go for the second case. Second case, A and B are exhaustible, which means, yes, please join. A union B is equal to whole of the sample space. So N of A union B will be equal to N of S. What is N of S? Cardinal number of S. Abhishek. What is N of S? Value. N. You see, this is the N, the total number of events. Okay. Now, what is P of A union B? N divided by N, which is equal to? Okay, rest of okay. I'll place a star mark because we will have to make a note of this one. You should not miss it. Okay. So P of S and P of A union B here. So what is P of S here? 1. Because in the numerator is total number of events N. In the denominator is total number of events N. N divided by N, 1. Okay, I should not forget this one. So ultimately, now let us go for the theorem from here. Yes, please join. P of, please join. P of A union B now becomes 1. So I need not write it. Let me write it as 1 is equal to P of A. Please join. P of A intersection B வரும். A வரும்னா நான் இங்க என்ன கண்டிஷன் எடுத்திருக்கேன்? A and B exhaustive மட்டும் தான் எடுத்திருக்கேன். Okay. Now let me go for the third case. Where in this third case I'll be discussing both mutually exclusive and exhaustive. Okay, can you please join? Yes, case number 3. A and B are, yeah, please join. Mutually exclusive and exhaustive. So you're going to combine first and second case together. Okay, so here, from the first case, we have taken P of A intersection B equal to 0 because it's mutually exclusive. And from the second case, we have taken P of A union B equal to 1. It's exhaustive. Now what happens to this theorem? Is 1 is equal to P of A plus P of B. அவ்வளவுதான். அவ்வளவுதான். Okay. Yes, minus 0 vanishes. Is it okay? Fine. Shall I go for the fourth case? Fourth case. A and B are mutually exclusive, exhaustive, and equally likely. Follows from a priori definition. The very first definition, classical definition. Yes. In this case, P of A intersection B equal to 0. In this case, P of A union B equal to 1. In this case, yeah. P of A is equal to P of B. Now, instead of applying this one, I'm going to apply this one over here. 1 is equal to P of A is equal to P of B. So I can write it as P of A plus P of A itself. Is it right? So this will be 1 is equal to 2 times of P of A. So P of A is equal to half. Ultimately, P of B is also half. That's what we say as equally likely, equally probable. Okay. So this is with respect to 2 events. 3 events are எப்படி இருக்கும்? So நீங்க வந்து அப்படியே imagine பண்ணி போட போறீங்க. Not in detail, just in a script work பண்ண போறோம். Yes, please make a note of this one. Then you can try for 3 events. Two sets, sorry, 3 sets. Working only the fourth case. 3 sets now how you represent? A, B and C are all the 3. Mutually exclusive, exhaustive and equally likely. Okay. Mutually exclusive, what will happen? P of A intersection B intersection C is equal to exhaustive. Equally likely. Ultimate result while applying the theorem. P of A, P of B and P of C will be equal to 1 by 3. This is the ultimate result. You can just imagine if you are working with k number of items, that is sets or events, k sets or k events. Yes, what will happen? You will not represent as A, B, C, etc. You will represent as A1, A2 up to AK. Okay. So mutually exclusive. How you represent? Yeah, please join for P of A1 intersection A2 intersection up to AK is all equal to 0. Or else you can write this in short as P of intersection AK, not AK, AI, I is equal to 1 to K. இப்படி போடுவோம்ல அந்த சமேஷன் போடுவோம்ல நான் இருக்கா அதே மாதிரி ஃபார்மேட்ல. Okay. So this is all equal to 0. Then please join. Exhaustive is exhaustive. P of A1 equal to, yes, how you represent? இதான் எக்ஸாம்ல கேட்டிருக்காங்க, அதனால தான் ரெட்ல போட்டுட்டு இருக்கேன். Okay, then equally likely. P of A1 equal to P of A2. Okay, ultimate result. P of A1 equal to P of A2 equal to P of AK is all equal to. Okay, that's it for 60% of probability over. Hereafter, I have to go for the third definition, axiomatic, or what is called as modern definition. How many definitions we have in total? 3 definitions. First one, classical definition, or called as a priori definition. Second one, statistical definition, also called as limiting form definition. And third one, axiomatic definition, or what you call as a modern definition. இது வரைக்கும் நம்ம ஃபர்ஸ்ட் டெஃபினேஷன் செகண்ட் டெஃபினேஷன்ல என்னென்ன படிச்சோம் அது எல்லாமே பாயிண்ட் பை பாயிண்டா போட்டா தட்ஸ் அபவுட் மாடர்ன் டெஃபினேஷன் வாட் யூ கால் as axioms is the properties of features which we have grabbed. Okay, please highlight. Let me consider a set A. See, so far I was discussing or using the term A is an event, or we can take this as set. You remember? Okay, so here we are considering A set. And what is the nature of A here is, it's contained in S, not properly contained. In the notation put another. In the notation put another. This is for proper set. You remember? This is for subset. This is for proper subset. This is for subset. So here I am taking a set A, which is a subset of S. What is S? Sample space. Sample space வந்து ஒரு subset இருக்கிறேன். Then I can talk a function which is a probability value named as P of A. Usually function எப்படி note பண்ணோம்னா f of A, f of x. Remember? இதுதானே போடுவோம் f of x, f of A. Here they are naming this as P of A because you are going to talk about probability value. And this function is what you call as a real valued function, which means it will not take imaginary value. What is the range of P of A? It will lie between 0 to 1. So it's a real valued function. If P satisfies the following axioms, see first one, P of A greater than or equal to 0. What do you mean by P of A greater than or equal to 0? It can be an impossible event or more than that. Equal to 0 means impossible. Greater than 0 means some value lying between 0 and 1. For every A is not less than or equal to, please make a correction, is contained in. Okay, contained in S. What's the second one? P of S is equal to 1. We actually say it's nothing but exhaustive. Right? P of S is equal to 1 means exhaustive. And third one, for any sequence of mutually exclusive events A1, A2, infinitely it goes means, then I can pull up all the values and have the probability value as P of A1 plus P of A2 plus P of A3, etc. See, at the latest case, I was working for K. You remember? I was working for K sets. If there are infinite sets, how will you work out this one? If there are infinite sets, A1, A2, A3, A4 goes on. There is no stop, infinite set. Up எப்படி போடுவீங்க? P of A1 intersection A2 intersection goes on is equal to P of A1 plus P of this. I'm working only for mutual exclusive. P of A1 plus P of A2 plus P of A3. It will go on. Am I right? So this is what they're talking here. The third one, for any sequence of mutually exclusive events A1, A2 goes on. Okay, so in this case, I can write this as P of A1 union A2, not union, but intersection. Intersection is equal to P of A1 plus P of A2 plus P of A3 and etc. Is it okay? So this is the axiomatic definition. Exam point of view. This was once asked in the exam. This was asked in the exam. This was asked. This was asked. This was asked. Okay, intersection. Next, let me go for question number 9. Shall I take over? Question number 9. A number is selected from the first 25 natural numbers. What is the probability that it would be divisible by 4 or 7? Please try to understand. 4 or 7 it is mentioned. Another common factor, common factor is common number. See, if I talk about 3 and 6, there is common in that. Okay. If I talk about 2 and 5, is there anything common? No. 4 and 7 is not common. Upper I can apply this theorem where A and B are mutually exclusive. Okay. Actually, I'm not going to work out this problem in this direct way. Instead, what I'm going to do here is, how are you going to understand this problem? 1, 2, 3, 4, 5, 6, 7, 8, help Allah. 11, 12, 13, 14, 15, 16, 17. So next edition a number la maatram. 18, 19, 20, 21, 22, 23, 24, 25. Okay. The 25 natural numbers are given here. Okay. The number divisible by 4. Yes, please list it out. And let me take this as A. So 1, 2. So let me list it out here. 4, 8, 12, 16, 20, 24. Number divisible by 7. Yeah. Let me name it as B. So 7, 14, 21. அவ்வளவுதான்ல. Okay. Actually, what we can do here is, let me take 25 and I write this in terms of 4. 4 6 are இப்படி பண்ணலாமா? கொஞ்சம் childish-ஆ இருக்கும். Please try to bear with me. 25 long division method. Okay. Yes, 4, 6, 24, 1. You can represent this as QRT rule. படிச்சிருக்கீங்களா? 4, 6, 1. Okay. Or you can write it in equation format. 6 into 4 plus 1. Am I right? So if I write this as 25 is equal to 6 into 4 plus 1, then how many factors I have in this 25? 6 factors. 1, 2, 3, 4, 5, 6. So what is n of A? 6. Now go for B. பார்த்தாலே தெரியுது மூணே நம்பர் தானே இருக்கு. அதுக்கே அவ்வளவு கஷ்டப்படுறீங்க. Okay, make it simple. 25 divide by 7. 3s are 21. Okay. So நீ வீட்டுக்கு போனோம்னா என்ன படிச்சீங்க? Long division. What's the remainder? 4. Write in equation format. 25 is equal to 3 times of 7 plus the remainder 4. What's n of B? Okay. So obviously, what is the probability of A? 6 divided by 25. What is the probability of B? 3 divided by 25. They're asking divisible by 4 or divisible by 7. Actually, if you apply the theorem, P of A union B is equal to P of A plus P of B minus P of A intersection B. Okay, what is A intersection B here? A intersection B is divisible by 4 and divisible by 7 also. There is nothing common. There is no common factor. So I can remove this one. That's why we say A and B are mutually exclusive here. Okay, so what is P of A union B? Directly you can add. What is P of A? 6 by 25. What is P of B? 3 by 25. So totally 9 by 25 is the answer. Is it okay? If this is okay, you can go for question number 11. Yes, please. In the same manner. Common இருக்குல்ல 1000 நம்பர் இருக்கும்போது ஏதாவது ஒன்று காமனா வந்துடும். ஓ அது எப்படின்னு கேட்பீங்களா? I'll discuss it. இது okay தானே? QRD rule. Here will be the divisor, here will be the quotient, and here will be the remainder. If you want to write it in the equation format, now quotient into divisor plus remainder. எவ்வளவுலாம் சொல்லாதீங்க, உங்களுக்கு புரியலன்னா விட்டுருங்க. Okay, let me go for the next question. Want to make a note of it? Yes. The next question, that is question number 11. It is not following directly from the theorem, but this concept will be used. So here we have, a number is selected for random from the first 1000 natural numbers. What is the probability that it would be a multiple of 5 or 9? Okay. So let me go for 1000 numbers. என்ன பண்ணலாம்? 1 2 3 எழுதலாமா விட்டுடலாமா? Thank you, Pa. First, we have to check whether it's divisible by multiple of 5 or divisible by 5. Okay. How we check? Take 1000. Okay, you have to divide it, right? Divide by 5. In how many ways you can do it? 200. So this can be written as 200 into 5. So if you are defining this as event A, then probability of A is nothing but 200. Okay, the quotient will be the value. Then second, divisible by 9. Divisible by 9. So you take 1000 divide by 9. Triple 1 now. 999 and the remainder is 1. So if you write it in equation format, this is going to be 111 into 9 plus 1. So if you take this as B, then P of B is equal to triple one. Then third one, we have to check with, because when we talk about a very big number, chinna number ada paravalla. If you are talking about very big number, 1000, definitely you have a number which is both divisible by 4, 5 and 9. Because how are you going to check? How are you going to check? 5 into 9 is 45. Okay, you check next number, 90. It will be divisible by 5 and also by 9. Okay, if you check the very next number, 135, it will be divisible by 9 and 5. So, then the number divisible by 135 mari eduthuko. So, not 135, 45 mari. Okay, number divisible by 45. So, if you split in this way, yes, how can you take 1000? 1000 can be taken as, if you divide by 45, 22. So, 22 is how much? 9, 89, I think. Correct? 980, yeah? 90. Okay. So, reminder is 10. So, this is 22 into 45 plus 10. So, what's the value? P of, what's the value here? P of is equal to 22. So, this is actually 200 divided by 1000. This is triple one divided by 1000. This is 22 divided by. Okay. இங்க வந்து intersection வரும். Union வராது. Because I am considering 5 into 9. See, I'll do the small working here. We are considering 5 into 9. Into means what? Intersection. Okay, then. So I think we have to make a small correction over there in the material. The material I have taken as the other way. Okay, material on the complete. So you can just make a note of this one, but directly. Question number 10 is fine. Question number 10. You want to make a note? So question number 10 and question number 1 are both the same, so I'm not repeating that. Question number 12. It's a very direct problem of the application of the theorem. Here is the accountant job. The probability that an accountant job applicant has a BCom degree is 0.85. CA is 0.30. Both BCom and CA is 0.25. Out of 500 applicants, how many would be BCom or CA? Or means what? Union. So directly apply the theorem and just fit the values. Done. Let me go for question number 13. P of A minus B is given to be 1 by 5. P of A is given to be 1 by 3. P of A dash P of B. This P of B is given to be half. What is the probability that out of the two events A and B, only B would occur? Only B would occur means I have to find P of B minus A. Only B na another B minus A then. So I have to talk about P of B minus A. So you remember that Venn diagram? This is A, this is B. Okay, A, B. B minus A means I need to talk only about this one. So from P of B, if I take P of A completely, I will get what? So not A. P of A intersection B. Completely, I'll get P of B alone. So I need to know the value of P of B and P of A intersection B. So let me go for the board work for convenience sake. Just tell me the value P of A minus B is equal to 1 by 5. P of A is given to be 1 by 3. P of B is given to be 1 by 2. We need to find P of B, P, B dash of B minus A. Only B would occur. B minus A. So this is P of B minus P of A intersection B. I have the P value of P of B. This is half minus. I have to find this one. So if I go with this, this is P of A minus B can be written as P of A minus P of A intersection B. Amalia, from the Venn diagram, this is A, this is B. I'm talking about A minus B means I'm talking about this area. Okay, which means I don't want this area. So P of A is the whole of A intersection B. I am removing the common area out. So this is now P of A 1 by 3 minus P of A intersection B. I can find it, but I know this value of 1 by 5. So to find this value, P of A intersection B, I take this to the other side. So this will be 1 minus 3 divided by 1 minus 5. What's the value for? Value 2 by 15. So let me substitute over here. 1 by 2 minus 2 by 50, 11 by 30. This is often repeated question. If you have any doubts, we'll get it clarified immediately, please. Next set. Say I have this is the last set of events. Dependent and independent events in Kalia. So let me go for that one. Just consider that I have a basket. Okay. In that there are 5 green balls and 5 black balls. Okay. I am player A. This is the sequence of events. Sequence marakudadu and dependent and independent sequence marakudadu. Event first event is I am A. I am the player A. I come to the box and pick a ball. Okay, probably I take a black ball. Okay, what is the probability of getting a black ball? 5 by 10. Okay, I take the ball. I see the ball and again I put it inside. Okay, please join. Again I put it inside. Now the second player comes. Just imagine you are the player B, and here player A, I think he was taking a black ball. Okay. Player B, I go with green ball. Your player B, you are choosing to select a green ball. So what is P of B? 5 by 10. Okay. Let me go one step backward. Here, as a player A, I have taken the ball and I have replaced it. I took the ball and I replaced it. Then how many balls will be there in the box? 5 green and 5 black alone. So it's 5 by 10. In case I have taken the ball and I did not replace. Not replaced. I did not replace. So how many balls will be there in the box now? 5 green and 4 black. Am I right? Here we will write as not P of B, we'll write as P of B where A has already happened. Let me write it over here. How we read this? Probability of B where A has already happened. I need not write A over here, not necessary. Okay, ஏன்னா இது என்ன சொல்லணும்னா replacement பண்ணிருக்காங்க, so we call this here as independent event. What event we call this as? Independent, because my event is not depending on the earlier player's event. But what happens in this case? A has taken the ball, that's why now the ball is not 10 in the box, it's now 9 in the box. So this happens to be a dependent event. Dependent on which? Event A. So I have to write this is P of B given A. So I read this is P of B given A, or P of B where A has already happened. P of B given A. Okay. Or I read this as P of B where A has already happened. So what's the value for? Yes, please join. What's the value? Picking up a green ball. What's the value? 5 by not 10, 9. See, it's only 9 balls over here. So 5 by 9. Okay. Now there comes a third player. Okay, there comes a third player. Player C. Okay. Let me go for this case where A came, ball பார்த்தாரு வச்சுட்டு போயிட்டாரு. B came, ball பார்த்தாரு வச்சுட்டு போயிட்டாரு. Replaced. Yes. What will be the, probably we'll go for black ball here. Tell me, what will be the black ball's probability? P of C is equal to, yeah, please join me. How many balls here? 5 green, 5 black. ஏன்னா A வந்தாரு பார்த்தாரு வச்சுட்டு போயிட்டாரு replace. B வந்தாரு பார்த்தாரு வச்சுட்டு போயிட்டாரு replace. So 5 black and 5 green. Yeah, value 5 by 10. In case this person B, player B, took the ball away. Okay. அப்ப எத்தனை balls இருக்கும்? 4 green, because the second player's event is picking a green ball. 4 green and 5 black. In this case, what would be the probability? P of, where is C போடக்கூடாது? P of, I want the description. C where A and B has already happened. This is what you call as dependent events. A or B நடந்த பிறகு C நடக்குது. ஆனா அது depend பண்ணி இருக்கு. This is not replace case I'm discussing. இல்ல ஒரு ஏதாவது ஒரு கேஸ்ல நாட் ரீப்ளேஸ்னாலும் போட வேண்டியதான். See, A has replaced. C by B மட்டும் போடக்கூடாது. It has to go in order only. Sequence of events தான் போடும். It has to go in order only. A and B has already happened. See, my condition is A and B has already happened. Whether A has replaced or not, you need not worry about that. We are talking about B has not replaced. Appo something happened with A, then happened with B, then comes to C. So ordering. Okay. So P of C where A and B has already happened. What's the value? Talking about a black ball. 5 by 9. Why it is 9? Because totally 9 balls are here. So I'll place a star mark. Okay. Now I come for this case. In case what happened is first player A came, he did not replace, so the number of balls was reduced. Then player B came. There may be a case where he replaced the green ball or he did not replace the green ball. Okay. Now tell me, what's the probability? Probability of C. Yes, tell me. Probability of C or C given A by A intersection B. Inga not replaced illa. Not replaced or not, it's relying on the earlier one. So P of C where A and B has already happened value. So what is the number of balls here? Already it was 5 green and 4 P. Now he is replacing. So 5 green and 4 P. So totally 9 number of balls. Yes, value 4 by 9. Am I right? Then here this case. Replaced, not replaced, not replaced. So this is 4 green and 4 black. Yeah. P of description. P of C where A and B has already taken place. Value 4 by 8. So I place a star mark over here also. So this one and this one. Okay. So you'll not write directly P of A or P of B or P of C. If it is replacement done, each and every step replacement done, one step replacement not done, you have to write it in this format. This probability is what you call as a conditional probability. Okay. And the events. So, enna terms we are discussing all these terms. One is dependent event. Okay. One is independent event. And the probability, description of this probability is what you call as the conditional probability. Okay. And also we'll be using the term what is joint probability. Okay. Joint probability. Other than joint probability. If you want to make a note of this, please join. P of A intersection B. Yes. Shall I write it as P of A into P of B? Actually, mutually exclusive general. See, usually we get this confusion. Mutually exclusive, we write it as P of A intersection B is equal to 0. Null set na A intersection B. Talking about value. 0. But when we talk about dependent or independent events, I cannot write this as P of A intersection B equal to 0 because I'm not talking about A and B are mutually exclusive. A and B mutually exclusive ஒரு ட்ரையல்குள்ள இருக்கும். ஒரு ட்ரையல்குள்ளே பார்த்துட்டே போனா if I talk about tossing a coin, A is getting a head, B is getting a tail. It's happening within the trial. But dependent and independent events A is the first trial, B is the second trial. I mean, like A is player A. He is coming and picking up the ball, replacing or not replacing, whatever it is. Second player comes, naming as B. Of a number of trials, more than one will come, we'll talk about dependent and independent events. Okay, so P of A intersection B in general. Intersection means what, per? And means multiplication. Okay, in the logic lavanga. So P of A intersection B is P of A into P of B. This is in the case of where A and B are independent. Okay, if A and B are dependent means we'll write this as P of A intersection B is equal to, first what happens in the player varada A. So we have to go in order. P of A into then who comes? Player B. How will I write this one? P of B given where A has happened already. கொஞ்சம் note பண்ணுங்க, ரொம்ப ரொம்ப important. This is what I call as joint probability. Okay, this is what I call as joint probability. Because you are joining the two events. Two events is two trials. This one alone is what you call as conditional probability because P of B where A has already happened. Okay. Also this you call as multiplication theorem. P of A union B equal to போட்டீங்கல்ல அது addition theorem. இது வந்து என்னது multiplication theorem. Okay. If I'm talking about three events, so this I was talking about two trials. Okay. If I'm talking about three trials, yes, please join with me, Pa. P of A intersection B intersection C, where all the three are independent. அப்ப என்ன போடுவீங்க? P of A into P of B into P of C. Now, dependent. அப்ப என்ன போடுவீங்க? P of A intersection B intersection C is equal to, yeah, please. Given A. Yes, this is the order followed. இதெல்லாமே மொத்தமா சேர்த்து பார்த்தா we'll call this as multiplication theorem. You're involving this multiplication here. You're joining the probabilities. That's why I call this as joint probability. And this one is what you call as the conditional probability. Okay, you need not make a note of it. It's there in the material. Kindly join. Please pay attention. Conditional probability, compound theorem or multiplication theorem. You're combining everything. That's why you call this as compound or joint probability. You can write this way, right? See, when I have P of A intersection B is equal to P of A into P of B given A. Up and I do. You write this as P of B given A, which is cross multiplying. Up then I know P of A intersection B divided by P of B. So this one is given. In case A, B, C, badra, player B is coming and playing the first event. Up and now I'll be writing, see, instead of this order A, B, C, see, A, B, C is player A, event A, player B, event B. Ipa nana panana game maatra. First player B comes, then how will I write? P of B. Okay. Then player A comes and it's dependent. How I write? P of A given B. Okay, and then player C comes. P of C where A and B has already happened. A intersection B potana, B intersection A potana, same now. Okay, now if you're talking about A first, then B now it will take this order. If you talk the reverse way, B first now it has to come over here. And B நடந்த பிறகு தான் A நடக்குது. So it has to be taken in the reverse way. So what will be the theorem? P of A intersection B divided by P of B. And please make a note, this should not be an impossible event. ஏன்னா இந்த நம்பர்ல போன denominatorல வந்து equal to 0 value இருக்க முடியாது. It should not be an impossible event. Please highlight, it should not be an impossible. Greater than 0 means what? It should not be equal to 0. Am I right? Greater than 0 means it should not be equal to 0. Okay, so these two done. This one all is okay. Is not dependent now, you can directly write it as P of B given A is equal to P of B alone. Not dependent now, we can write it as this one. This is asked many times in the exam. So in this case, we will say P of A intersection B is equal to P of A into P of B. Okay. Impliedness, If A and B are independent, then please make a note. A and B dash are independent. A dash and B are independent. A dash and B dash, everything are independent. ஒரு இது டிபெண்டன்ட் ஆனாதான் மிச்ச அதோட காம்ப்ளிமெண்டரி ஈவெண்ட்ஸ் எல்லாம் டிபெண்டன்டா இருக்கும். இல்லைன்னா எல்லாமே இண்டிபெண்டன்ட் தான். கொஞ்சம் நோட் பண்ணிக்கோங்க. So A and B means that comes along with the other three pairs. A dash and B dash, A dash and B, A and B dash. Everything will come along with that. So if I talk about P of A intersection B dash, I can write as P of A into P of B dash. Am I right? So P of A as it is, P of B dash can be written as 1 minus P of B. Okay then. So then you can then I request you to go through. Idame over. I have completed. Okay. Theorem of compound probability over. I have completed. This one also I have completed. This one also. Okay. So concept over now. So tomorrow we'll be discussing the problems. Okay. So I request you to go through the concept before coming for tomorrow's class. Question number 15 under I have to discuss the question number 26 of yes, the last question number 26. Then one small concept will be left over. This I'll discuss tomorrow.